Yes, hello students. Today we will discuss the JEE part and competitive part of basic facts on dynamics of charge particle in uniform electric field. It's the behavior of electric charge in uniform electric field. Yes, in any electric field, as we know in previous class, any electric field is given unless and until it is mentioned, it is to be assumed to be uniform. And in any given electric field, if a charge is present, we have to identify the following one by one things. Once you start practicing and you start identifying, it is very easy to understand the behavior of the charge. First, you have to observe the charge, whatever you want to understand the dynamics in a uniform electric field. You have to find out or observe what is its nature and magnitude of the charge particle. Plus Q, the charge, what's the nature? Either it's a positive or negative, and its magnitude. Example, if they given the electron, then it is going to be negative charge, and its magnitude, we know that 1.6 into 10 raised to minus 19. It's a fundamental charge, negative charge. And similarly, example for a positive charge, if the proton is given in a uniform electric field, a proton is kept, then it is a, we know that it's a plus 1.6 in 10 raised to minus 19. Other than these two, if any charge is given, you must be very careful, is a positive or negative, and its magnitude. Frequently, they use it electron and proton. Observe the nature and magnitude. Second, mass. The mass of the charge. If the other than electron or proton is given, you have to observe and note down the its given mass. The mass has to be given. Sometimes if they mention electron and proton, they will not mention the electron and proton mass because they are standard masses. We know that electron mass and proton mass. Here too, we must know the Q, its nature and its mass. And third one, you have to identify the direction of uniform electric field. In the given thing, they had to mention or the given the diagram. In that diagram or in the theoretical way of defining the electric field, you have to first identify the direction of uniform electric field direction. And fourth one, it is very important. You have to note down the initial velocity of a charge particle. If the charge particle is, if they're moving or it is at rest at the initially, you have to identify. That's the initial velocity identifying is very, very important because we are understanding the dynamics of a charge particle. Its initial velocity is very important. You have to identify if it's at rest, initial velocity, I am representing it by V naught. If it's at rest, it is going to be 0. Or if it is initial velocity, it has a certain initial velocity, then it should be greater than 0. And the next important thing is, these two are very important, and identifying an initial velocity and finding the, if initial velocity is there, then we know that it is a vector quantity velocity. Hence, you have to identify the direction of initial velocity V naught of the charge particle with electric field direction, because we are observing the behavior of the given charge particle in electric field. We must compare or identify the direction of initial velocity with respect to electric field. Next, sixth one, a charge particle electric field experiences. We know that a charge particle in uniform electric field experience the Coulombic force or electrostatic force. F is equal to EQ, where F is the Coulombic or electrostatic force, E is the uniform electric field intensity magnitude, Q is the magnitude of the charge. This is always it will experiences electric force which is independent of magnitude and direction of V naught. V naught comes either rest or any direction. It's immaterial of magnitude. Always that any charge, either it is at rest or in motion, once it comes in electric field or uniform electric field, it experiences the Coulombic force, electrostatic force or electric force. F is equal to EQ at all the points is going to be remain same because it is a uniform electric field. Seventh, this is the most important thing. You have to decide the direction of F. What is this F? F is this. Coulombic force direction magnitude is this. Then what is this direction? We know that if the positive charge, electrostatic force of this positive charge in the uniform electric field is in the direction of E. Means Q experience the force in the direction of electric intensity direction only. If the charge is negative, then it experiences the force opposite to electrostatic force. Electric intensity. Then eighth one, check the event. What is this event? After once charge is given inside the electric field, you have to observe how the charge is, whether it is a stationary or it is moving. That is the other terms they are using in frequently in exam is whether the given charge particle is at rest, sometimes they mention the purely at rest, or hanging. They're telling that this is going to be in air, it's a hanging, or standstill, all are same. Where initial velocity in this case is 0, it's a rest. Or it is moving. If it is a moving, it experiences the force. Once the any body experiences the force, it must accelerate. Then either it has to moving or means accelerating, or it is to be rest. You have to identify all these 8 points very clearly. Then once you start understanding these all 8 points about a charge particle in a uniform electric field, then remaining things are going to be very, very easy. First, identify all these things by going for the previous classes. Then only we can go for the understanding the what exactly the dynamics of charge particle in uniform electric field. Yes, we'll practice this first for a charge particle. I have taken one example. These are the uniform field where you can observe in the tests or in any exam. This is a uniform electric field where the field direction is going to be all are horizontal. We are going to, this is a electric field. These arrow marks represent the direction of electric field. Here we have to represent all these things. This is a horizontal uniform electric field. This is in the right to left, right to left. This is horizontal. This is called vertical. Vertical means other two direction. One is vertical uniform electric field vertically downward, means it is going to be like this, and vertically upward. These are the 4 figures you frequently come across in the problems. The dynamics of charge particle in uniform electric field. See, before going to this, I think is better we're going to practice once in this all these 8 points here. Identify very clearly. I will take first a positive charge. I will take a positive charge, a concrete example. The first I will take proton. If I am going to keep a proton here, see everywhere I will keep in a proton E plus. I will represent it by E plus. Next, here we have to identify electric field. See, the electric field direction is, this is the electric field direction. This is a electric field direction, arrow mark, there is no need. Then you have to simply write the E. This is a uniform electric field. Next, I am observing all these basic facts only with respect to positive charge. I am taking a proton E plus. This observe the nature of this is a positive charge is over this. Then mass of the charge particle. What is this mass? The proton mass. The mass of this one is m. I am considering this is m only, not me. Don't get confused me plus and all those things. If I represent more orbitally number, then it is very difficult in a equation to substitute. That's why make it as a single charge, represent it by is simply the mass is going to be m. The mass is simply small m. Then mass is m, where m is 1.67 into 10 raised to minus 27 kg. It is in a proton. And identify the direction of uniform electric field. I already identified. The third one is also over. Then note the initial velocity of the charged particle is at rest or moving. Imagine it is at rest. Let it be here. It is going to be at rest. Then I am writing this is going to be v naught. This is a initial velocity is going to be v naught. Let this is going to be 0 at rest. This is over. Greater than 0, you will see next. Identify the direction of initial velocity. Yes, this is going to be of each particle. This is everywhere. It is going to be I placed with at rest. Then if I want to keep at rest, it will experience the force. Either it moves, because the force experienced is independent of the magnitude of the velocity and direction. Either whatever the direction or whatever the velocity, it will experience the electrostatic force. Yes, now charged particle, what is that force? F is your magnitude is F is equal to EQ. Electric force which is independent of magnitude and direction of its V naught. Decide the direction of, the sixth is also over. Then decide the direction of F. This F direction, magnitude is EQ, E is this magnitude, Q is E. Then we know that the force is, magnitude is E into E. Then what is the direction? Direction is now, if plus Q, positive charge is kept, the force acting on it is in the direction of E. We know this. This will experience the force in the direction here, direction of E. This is what the student must understand clearly. Once these things is going to be understood, then only mathematics remains. This is the, a positive charge experience the Coulombic force in a uniform electric field in the direction of a Coulombic force experienced by a positive charge is in the direction of electric field. Means this is the direction. Here force is in the direction, positive charge in the direction of electric field. This is the F. This is the F. Here, this is electric field direction is this. You simply don't say anything. Only thing is in the direction of electric field, Coulombic force experienced by a positive charge. This is upward. Then what is the Coulombic force magnitude? Magnitude is F is equal to, that is E. That F is EQ, E into Q. What is E? E is electric intensity. Q is a positive charge. This is magnitude is E. This is F, E. And here, this is a positive, means here, this is positive because F and E both are in F. This is a vector. This is a vector. All are in the direction of electric intensity. Coulombic force or electric force experienced by a positive charge in an electric field is in the direction of electric intensity. Means this is the direction of electric intensity. F is this. E, F, E, F, E, F. The same way I am representing an electron. You take anywhere. E minus. Now, what's the E minus? E minus, first the charge is minus Q. This is going to be E minus. And the mass is 9.1 into 10 raised to minus 31. Then second is over. Then identify the direction of uniform electric field. We know this direction of electric field. It will not going to change. It is fixed. The only thing is initial velocity V naught. I'm going to consider this is a E everywhere. Initial velocity, let it be V naught. This is V naught. This let it be. This is going to be initially kept at rest. V naught is 0. Now, Coulombic force experienced by this charge. The Coulombic force is going to be E into minus Q. This is E minus. What is this? We'll see. Magnitude is same. F is equal to EQ. E is the electric intensity. Q is negative electron. That's the difference. Now, the direction of electric intensity. Decide the direction of F. If the direction of F is direction of F is zero. Now, electron, a negative charge in electric field experience electric force opposite to direction of electric intensity. Minus QF is opposite to E. This is the F. F is opposite to E is this. F is this. Simply you have to go on putting the direction. That's it. Opposite to E. My negative opposite to E. E minus opposite to E. E is this. Sorry, here E is this. F is acting opposite to this. This direction of Coulombic force. And minus sign represents that Coulombic force F is minus E. What is this minus represent? F and E, because these two are vector quantity. We have to compare only these two. F and E are in opposite direction. F and E opposite. Negative charge. F and E opposite. F and E opposite. F and E opposite. These are the things every student must understand. This is the basic of a charge, behavior of a charged particle in uniform electric field. Yes, we'll understand this further. What is its dynamics is.